Hello everyone, my name is Guilherme, welcome to another video, and I'd like to make this video to discuss a little bit and showcase about how does it looks like to create your own game with no commercial game engine, meaning that you are the one creating your own code base, your own game and technology and everything. Because you guys know, like lately we have been bombarded with this Unity drama and so on. Honestly, if you read carefully, I don't want to go into the details here because this channel does not talk about Unity, but it's not going to impact everyone. But I get it, and I agree that this is a huge problem, a huge headache, and so on. So many people are thinking out about how to move on from this, and some people want to change engines, and some people want to get rid of engines and never use it anymore. So I'd like to discuss a little bit more about how does it look like to not have an engine. This is, if you're not familiar with this channel, the engine that you are seeing this in your screen at this exact moment is called Cave Engine, and it is my game engine. I've written every single code of this. It's about 100,000 lines of code at this moment, and I've been working on this for 8 years. I'm a senior game developer, and I do this because I love game engine development. I really like this. And in this month, it happens to be the first month that I'm working on my game, like my next big game using this engine. I'm not showing anything about this game in particular in this video, so this is just a bunch of test scenes and demos to showcase stuff for you guys, but it is being an interesting month because I'm working in features for the engine that I want to use in my game. So I'd like to discuss and showcase to you a little bit of how does it look like to not have an engine, to not rely on anything. So let's talk about this in this video. And hopefully it will help someone here to, I don't know, decide to not use an engine or decide to use an engine. First things first, game engine development is not easy, and unless you really want to make engines, I don't recommend you to go this way. So keep that in mind. I'm not trying to convince people to, hey, you should stop using Unity or Godot or whatever and just make your own game engine. This is not the point of this video. The point of this video, again, is to showcase what I'm doing here in this scenario. Okay, so let's talk a little bit about all that. So one thing to keep in mind is that I'm making the game, but I don't exactly not have a game engine. I do have a game engine, but this engine happens to be my engine, so it's a little bit different from everything else and anyone else because I'm the one responsible for 100% of it. I'm the one responsible for the licenses. Of course, I wrote the entire thing, so it's my license. If I want, I can say that, well, you're not allowed to use this engine. I am not allowed to use my engine unless I paint my hair black or green, whatever, because it's my engine. Of course, I'm not going to do this, but you got the point. So you have this advantage of owning the technology, so you own everything and you don't need to worry about that like at all. Any time in your entire life, you don't need to worry about that. What you maybe could be problematic if you are using like a third-party library and they change the licenses because this can happen. But in this case, it's not a real trouble as it will be if you're using like an entire game engine and they change the license, for example. I do use SDL at the moment, and I'm planning to drop this because I don't know. I'll talk about that in a second, but maybe SDL tomorrow will change the license and it will charge me $1 per install of my engine or whatever crap it is. Well, what I would do is just open Visual Studio here, open my engine, and just, hey, I do completely, like, I'll search for everywhere that I'm including SDL, so you can see here I'm using it, and then I will delete this include, and I spend 1 day or two writing the all operational system implementations, and I'm not gonna use SDL anymore. I waste 1 day of my life, but that's it. And I know how to do it without SDL, and that's why I'm planning to drop stuff from Cave, because as I learn as a game engine developer, I tend to prefer to use my own technology because I have control, and this is the most important thing. You know, you don't need to worry about stuff changing. You own the stuff, and if something changes, well, you can rewrite. Let's say that Microsoft does a dumb stuff for Windows, and no one is using Windows anymore, and now everyone is using Linux. Well, Linux. I don't know how to pronounce that in English. Anyways, it will take me a week, of course. I will have to write like a makefile and so on, but I will make the engine work on Linux, and that's it. So you have this freedom, and it's great. So this is a good point of having your own engine, and you can do features like if you don't like using C# in to make your stuff, as I don't like using C#. I like Python, and this is like a particular opinion. Well, guess what? I'm using Python in my engine because it's my engine. I can write Python stuff here. I can make it work with Python. So this is an actual code that works here. I was testing the root motion, and I talked about that in the previous video. So I'm not going to talk about this again in this video. I was showcasing all that. And this is not a showcase video, but you can write the stuff that you want. And if you get sick of it, and tomorrow if I finally agree with Jonathan Blow and say that the scripting languages is bad and I want to use C++ to write the scripting of the engine, well, guess what? I will be able to do this, and no one will bother me. I don't have to complain on Reddit or whatever. I can just write the stuff I want, and that's it. I don't care about the rest of the world. I can write this stuff. So this is a good point. But what is the drawbacks of having an engine? Well, first things first, as I said in this video, this is probably like an 100,000 or more lines of code stuff that I've been writing for like the past 8 years of my life. It's not easy. It's very hard to make something like there's very performant. For example, this character moving here, I can add like a bunch of copies of this character, and I may crash and may not crash. It does not crash at this moment, but I'm just saying that if you're developing this, well, you find crashes and you have to spend like days or weeks or months that you probably could use to make your game, fixing crashes and improving stuff that, well, this is important. This is part of game engine development process, and you need to know that, you need to be aware of that, because if you're not, you'll get frustrated. So this is part of the process, okay? And this could be like a negative point, but for me, since I'm very interested in learning how this technology works, it's not very bad for me. Like, I like this. I like to spend time learning stuff and implementing features and so on. This is good in my opinion, for me, like for my specific case, you know. So you gotta be aware of that if you're making a game engine. And how does it looks like to implement features? What kind of features do you need to implement? Well, this is great, and I'll talk about this right now. I'll give you a moment. So we have this capoeira guy here. This guy is moving here, running some, anyways, some animation. This is a mix-sum animation, and it turns out that making animation in a game engine is very complicated, like takes a lot of time. Oh, this is just like a side note. When you make game engine, you learn stuff, and you learn a lot of stuff. You learn a very deep knowledge. You understand very well. You must have to. Like, there's no point, or there's no other option to not learn very well how things works. And this is a very good point in my opinion. I really like to learn how stuff works, and it's not easy to do. Maybe it will mean that you're gonna have to waste a year of your life. You have to read a 1,000 pages book about a very technical stuff. You need to ask questions, read documentations, and spend time, fail a lot of times, but in the end you will learn how stuff works. And honestly, I love this. It's very good. So going back to rendering and to animations, this is an animation. Skeleton animation is not easy to do in a game engine. It does have a lot of problems, and it does have a lot of importing issues, because you are working with FBX, with .blend files, with OBJ. OBJ does not have animation, so whatever. Collada files and so on. So we need to understand how to import, how to translate that into your own data format, and this is not easy. It's very annoying, and you have a bunch of other smaller problems. For example, this capoeira animation, I have this here in Blender, the exact same animation that I'm using in Cave. Let's see if this character does have, I just imported for this video. Yeah, it does have the same materials here in Cave. You can see here. It's not adjusted properly here in Blender, but this is not important. What it is important is the animation. And something interesting that I've been working on, and I want to show this, is why I'm here. I want to showcase what I've been, how does it look like, what kind of features we will waste your time, or invest your time, not exactly waste, implementing if you go to the no game engine road. So this is the animation. And something that people don't understand, like people don't think about, but when you are making your own game engine, you must think about is um, everything that is going on to make these appear on the screen. So this is the animation in Blender, great. But how can I make this same thing work in my game engine? How can I make this translate to this, right? And there's a lot of stuff involved. By the way, I do have root motion. That's why the character is lighting. You probably saw me like turning this off and on in this video. And this is great as well. I'm not gonna talk about this, but anyways, how to translate this animation from Blender to the animation in the engine. And something that I was working like this morning, today is Sunday, and I was working this Sunday morning on this feature is how can I get the keyframe because for every single bone here, so this is a bone, and this is something that people don't think about when you're using Unity or whatever. But if you're using an actual game engine, you need to think about this is an animation, and this animation is full of keyframes. And each keyframe here, for example, the hips, I do have the location, the rotation, and the scale. And it means that for when I evaluate this animation in the engine, of course, the character here, it does have, let me show you guys real quick, the debugger here. It does have all the information necessary to run this. It has like the minimum and the maximum frame. In Cave Engine, this is measured in seconds, not in frames. So that's why it's 103 here. And here, oh, it's 103. Anyways, it's in frame, but you can see below. Oh, anyways, internally it's in second. Trust me, I made change stuff to make it easier for us to translate this, but it's in seconds. And what is important is I do have the speed and a current frame. I can change this in Cave when I want. This is the loop count and so on. But for every single frame, let's say frame 14, let me make the speed 0 here so I can stop the animation, and you can see at this frame, let's go to the frame 32. I like 32. 42. So it's better. It's the answer for the universe. So I'm frame 42 and I'm stuck here at this pose. But if I go to Blender and open frame 42, you can see it is the same pose, but it means that to evaluate this for every single bone, I need to go ahead. Oh, this is bone. Let me enable this. Right up leg, right? But for this bone, I need to get the location, the rotation, and the scale. And there's a bunch of keyframes. So the question is, which keyframe do I need to have? Do I need to gather? And most importantly, is this in between these two frames? Because you can see in Blender, Blender is not allowing me to go between here, but in reality, you must have the option to go to the middle. So I'm here in 42.5, so I'm in the middle, and the engine actually blended those two keyframes. So the engine needed to understand that I want those two keyframes and I need to blend. So this might sound like a simple thing, but it's actually not, because you have a naive way to do this, which is like go to every single frame here and see if this is the correct frame. Or you can do some more advanced stuff, because it's not as easy to say, hey, I'm in frame 42, give me the keyframe 42. This is not easy, because it might not be a 42 keyframe here. So for example, I can delete this. So now I don't have a keyframe 42, and now I need to interpolate between 41 and 43. So it's not trivial to do this as well. And this is not trivial, again, to do. So we need to come up with a lot of strategies to do this fast and reliable, and in a way that you'll be able to evaluate all the bones for like 10 or 12 or 100 characters in a single frame without having like a very complicated class. And I'm explaining that because this is actually something that you will face if you decide to make a game engine. And this morning I was optimizing the system. I do have, like Cave Engine did have a previous system, but it was not very good and it was a little bit problematic. And the way I did is to reduce this into a bunch of smaller problems. For example, what if for this bone I don't have any keyframe? So what to do? How to handle if I don't have any keyframe? Well, this is one case, and it's trivial. In this case, Cave Engine will just return like a default. This is interesting. Let me show you. It will just return like a default vector here for the position and a quaternion for the rotation and so on. But there's another case. What if this only have one keyframe? Well, then it's trivial. I will return the same keyframe, as you can see here, throughout all the animation, and Cave Engine is handling this as well. But what if this keyframe is less than the first keyframe? As you can see here, it's 0. In this case, I will return the first keyframe. And what if it is greater than the last keyframe? In this case, I'm returning the last keyframe. So this sounds obvious, but then you start going to a less obvious situation, which is, well, what if it's in the middle? As I said, it's very naive to go ahead and iterate over all the keyframes. This is not good, especially in mix-sum animations. There's a lot of keyframes. This animation probably have like 100 keyframes per channel here, and I do have position, rotation, and scale channel for every single one of the 65 or 69, I think it's 69 frames, bones that this armature have. So this is not trivial to do. So how to solve that? Well, since I do have a graduation, and this is very important, you need to have a deep knowledge about programming. And I'm graduated in information systems, so I know about binary search. I know how to reduce like a time complexity. Let me try to draw stuff. I know how to reduce this time complexity, which is the naive approach, to something very easily to log n, which is way better than n. And if you don't know what this means, it's probably because we need to study a little bit more about programming and so on, because this will be required for you to make like this type of stuff. So the solution that I did here, and what I'm talking about ON, is that this approach will iterate over every single one of the keyframes. And how many keyframes do I have? I have n for the sake of this explanation, and until I find one. So this is a bad time complexity. But the log n is good, because if you take the logarithm of n, you end up with like a way smaller number, and this is going to be better. I'm not going to explain time complexity in this video, but in a nutshell, what I wanted to go ahead is I had to implement a binary search algorithm here to find the appropriate keyframes in a best case scenario. Okay, so what I did is I get the first frame and the last key frame. So let's say that I want to find the frames for the position 36. Okay, and then what I do is I split this in half. I get the middle of this, so this is the middle. And then I say, is this greater or less than the frame, which is 36? And then I realize that this is greater than, right? Because this is greater than 36. So what I do is I completely discard this entire part of the search field, and then I proceed to do the same thing for these subsections of the frame. So I split this again, and then I do the same checking for this. Is this greater or less? And in this case, is less. So what I do, I discard this. And then I do the same here. Split in the middle and do the same. And this is greater, so I discard this frame. And you can see that I can keep doing this until I find the exact one. And mathematically, this will be way faster and way more like performant than doing the other naive approach. So I had to implement this to make sure that my animation works faster and better, and it's more reliable, and I can use with more corner case and advanced rigs and so on. So this is typically something that I will do and working with game engine without an engine. This is something that if you're using Unity, Unreal, or Godot, it's not something that you have to worry about like at all, unless you're doing something really advanced, you know. But if you're working with no engine, you have to worry about that. So if this talk gave you a big migraine, a big headache, well, then maybe you should keep using the existing game engines. But if you're curious to understand a little bit more about how that works, maybe game engine development is for you. So you gotta keep that in mind. And of course, this is something important. I'm saying this, but this is like a general purpose way of handling this. And you can make, if you're making a game, not a game engine, so if you're making the technology behind your game for you to make, but you're not necessarily creating a general purpose game engine, as I'm doing here with Cave, you can optimize this because, for example, something that you can do that is very simple, and actually Cave Engine was doing this before, and I'll talk about why I'm changing this in a moment, is just cache the last keyframe. So you can do like a naive approach, but if you cache the last frame, so for example, in the past frame, in the past game engine cycle, I was using the frame 35, right? So it means that in the next time that I try to do this, that I try to gather this channel, there's a very high chance that I will start at 35. And it will probably going to be like 36, 37, or if the computer is really slow, like 42 or something like that. But if I start at 35, it's not going to be so heavy. So this is a good thing. This is a very simple way to solve a problem. It does not reduce time complexity when it comes to like proving, like doing the math, but it will make your program be a little bit smarter and faster, and this will going to be great. And Cave Engine was actually doing that. So it was caching the frame. The reason why I stopped doing that is it was not doing that like per armature, it was doing that like per animation. So if you have two characters playing the same animations in the scene, Cave Engine, we're not going to handle that well because it was only caching one of the characters' position. So this is something. And the other something is it will not going to work at all if you're playing the animation backwards. And this is something that I plan to do in Cave, because I was only caching forwards, not backwards. So it was not good, and that's why I decided to change this, because I want to allow the characters to move like forwards. So this is the animation forwards, but I can do a minus here. And you can see that it's now backwards. You can see that this number is decreasing. So it is working perfectly now because I changed that. So this is the type of stuff that you will spend your time thinking about and implementing if you decide to create your own custom-made in-house game engine. So yeah, that's it for this video. This is a little bit of a showcase and talk about how does it feels like to work. And I really like doing this. Some days I'm very productive. So let me show you my GitHub repository here real quick. So today I did two things here. I did a fix, very small fix here, so you can see here. And then I did this new optimization. You can see the diff here. Changed some stuff, it was nice. But then like some days I'm productive, very productive. So I implemented root motion. And yeah, as you can see here, I have a lot of fun doing this. But yeah, that's it. I hope this helped you to figure out if the game engine development is for you or not. And let me know in the comments if it is or not. And if it is for you, join my Discord server, because there's a lot of people there that develop game engines as well. So it would be great to talk about that and discuss. And if you have a question or a comment, you'll be able to talk a little bit, and that's great. Okay, so don't forget to leave a comment. My name is Guilherme. Thanks for watching this video. And oh, just something, a side note. This game engine, Cave Engine, is available for everyone to use. It's my engine, but I also released that. Not this particular version that I'm using, because I'm still developing this, but the older version is available, and it's great. I do have a lot of tutorials here in this channel, so if you are interested, just consider subscribing to this channel and checking the videos that I have, only if you're interested, you know, because yes, I think it's going to be great. So that's it for this video, folks. Thanks for watching, and I see you in the next one.